But it's actually something I always encourage people to do. You know, anytime you run a test, you should basically know what the result will be. Because
Yeah, so
otherwise, no,
we should basically know what we want from particular function or particular part of code.
yeah, you should never be in the situation where you're running a test and you just have no idea what's going to happen. Will it pass? Will it fail? Will it not compile? You should satisfy yourself as to this point before running the test, shouldn't you? Because what you're doing is you sort of have a mental model of what the program's going to do, and what you're checking is, does it actually do that? Because if there's a discrepancy between your model and reality, then that's something you need to fix. Or hopefully it'll just confirm what you already think, which it has. So, okay, so we can make this pass now fairly easily, can't we? We already have the code. It's just a case of repotting it.
So maybe, yeah. So now we expect it's much easier because we want safe landing.
Yeah, in fact, we already have the code, as I say, so we can just take it from main. And if it doesn't work, we'll soon know.
So basically, we can copy this code.
Yeah.
This is our test. This is landing. Okay. Okay. Saved. Okay. The math is imported here, our package, automatically by VS Code. So we have a situation that these conditions are checked here. Yeah.
I don't really know if it's necessary to call math.Abs here, because, you know, if you've just hit the ground, then your velocity is likely to be downwards. That seems a reasonable assumption.
Yeah.
But, you know, I never like to make even reasonable assumptions if I can avoid it. That's another part of this sort of defensive programming idea, isn't it? It's just assuming that I am, or knowing that I am fallible and wrong about a lot of things. So rather than just relying on me being right about something, about everything, I'll just say, suppose I'm not. Suppose there's some way that you can hit the ground with a negative velocity or something, in which case, well, I won't be vulnerable to that bug, will I?
Yeah.
So often, and I see other people doing the same thing where they comment in the code saying, this can never happen. but they know it can, which is why they wrote it that way.
Until it happens. Okay, so we need to refactor a little bit here to actually provide the writer.
Yeah, and as we know from Code Club, fumped printf is just a trivial wrapper around fumped fprintf, which always prints to standard out. That's convenient, of course, because that is mostly where we do want to print to, but not in this case.
So now we have the IO writer and then writer passed to fprint function. We have this.
I think this should pass. I'm willing to nail my colors to that prediction.
Let's give it a try. So let me clear. Okay. Go test. Wanted safe landing.
Interesting.
Yeah, landed too hard.
Okay, well at that velocity, that would actually be the right outcome. That is landing too hard.
Could be. Oh yes, my navigation there.
So the function is clearly absolutely correct here. It must be the test that's wrong, since that's the only thing that's left.
Let's have a look. Soft landing. Okay. What? Safe landing.
So we could ask, what is the state of the game at the point we call display result?
Yes, so here basically this is the initial state of the game, right? We didn't change any state here. We created this game object.
And we can refer to that to see what it is.
Yes, and where is this initial state? So then actually we need to create the state at the very beginning, because initial states are here. We have velocity -100.
Yeah. So if you assume that that's the moment the game ends, then it would indeed be a very hard landing. So, but we can set it to whatever we want, of course.
Okay, we can try here.
So, well, what that would do is change the game-winning conditions, isn't it?
Yes,
Whereas actually, I think
true.
the conditions
Yeah,
are
yeah.
okay. But what we're saying in the soft landing test is we're saying, suppose the velocity were less than 10, what message would the player see?
Oh, hard landing actually.
Yeah, and because it's a new game, but it's actually 100, so we can just set it to 9.1, can't we?
Okay.
That's what we're really saying. We're saying, given a G where the state dot velocity is 9.1, what message do you get from display result? And we think we should get this one.
So you think that we need to basically
We can reach in and tweak the knobs ourselves, can't we?
Yeah, so state, gravity, velocity.
We can leave everything else unchanged because actually display result doesn't look at anything else, does it? It only looks at velocity.
Yeah. Okay, so we can set up velocity to, for example, what, 9, for example?
Well, we've expected a message where it says 9.1, so that would be the logical thing to set it to.
9.1, yeah.
It can be anything less than 10, but let's go with that.
Yes, but yeah, so since we hard-coded here 9.1, yeah, makes sense, of course. So G-state velocity we have here, we want this, then we are displaying, so let's give it a go.
Mm-hmm. Wonderful.
Yeah.
That's some nice work. And the corresponding test for hard landing should be pretty easy, shouldn't it?
Yeah, so let's do this quickly. Maybe.
We already did the hard bit.
So hard landing displays a success, so basically no change. And we need to set up velocity.
Yeah, and we want to display result failure, don't we?
Yes, yes. So let's go to main. We have here landed too hard. Let's use this one. Just copy to.
And sometimes when I'm doing this sort of thing, people might well say, shouldn't this be a table test? Like, shouldn't you have a slice of test cases where with the first test case is velocity 9, result, expected result success. Second case is velocity 100, expected result failure, And my response is, yeah, okay, that's possible, but a table test does add a fair amount of complexity, doesn't it? I mean,
yeah, but it's a good idea to, for example, maybe you write this test like we are writing right now, and later on figure out, oh, maybe we can refactor, maybe not.
Yeah, that's exactly what I think. A table test is great, but it's not free because we have to add a struct type, and now we have a slice of struct literals, which adds a lot of code, and then we have to have a loop, and we have to call trun and all of this sort of thing. Is it really worth it for 2 cases? Not really. If we wanted to have 10 cases, then yeah, we probably would go with a table. But because I always want my tests to be as short, as simple, and as readable as possible, I'm willing to just write a bunch of quite brain dead tests rather than one complex but powerful test, which does a lot.
And it's easier to read, even though some structure is repeating.
Yeah, because I sort of feel like somebody like you should be able to just parachute in, run the tests, find that one test is failing, zero in on that one test, and fairly quickly identify what the problem is without having to read a bunch of other tests or a bunch of helper functions or, a whole bunch of stuff that is just kind of set up by the tests. It should be more or less, straight in, straight out, shouldn't it? And as you said,
this applies as well to every single developer who is joining the team, right? So we are repeating exactly the same situation.
Yeah, that's right. And as you said, I think often a table test will just kind of emerge when you find yourself writing the same test 10 times with just tiny changes. You think, yeah, actually, this could just be a table. That's fine. But I wouldn't start with a table, because once you do, you're sort of forcing yourself to fit everything into that paradigm. And it may not fit, For the failure case, you might want to do something quite different.
Yeah.
So this is fine, and we only need 2 cases, and 150 is definitely enough to cause a hard landing. So that's great. Are we passing yet?
So let's have a look. Okay.
Oh, close.
Too hard. Yeah. Didn't we float? Yeah, that's true.
Great. That's very nice.
Passing all tests, yeah.
Yeah, so we can now complete this refactoring by having main actually call this new method.
So our new method is here. So we have basically display result. Yeah.
Sounds good. And this presumably takes os.standard out.
Yeah, just to display this.
Yeah, and you might quite reasonably say, well, it kind of looks like we're passing stood out a bunch of times. Should we even need to pass that if it could be the default, which would make sense. And that's not a bad idea, is it? You could imagine that, once you're sending your output to one place at the beginning, you're not going to change that during the game. So, or you could, but it's unlikely. So you might say, well, why not just pass it to new game and say, create a new game which prints the standard out, and then you don't need to pass it everywhere else.
Oh yeah, so that we could introduce the new parameter to new game. Right?
Yeah, that's a possibility, isn't it? Let's just complete this first, and then we can think about that.
Okay, so shall we play the game? Or
let's get rid of that commented out code first, because thou shalt not suffer commented out code to live.
Exactly,
is my motto.
That's, I see this too common. So
I'm fond of saying that. I'm fond of saying that if you're a good programmer, your delete key should be worn out before any of the others on the keyboard, because you should spend most of your time doing this sort of thing, just getting rid of code. People might say, well, John, it seems like you're not deleting stuff so much as just moving it around between one file and another. And I'm like, yeah, welcome to programming. That's what we do. So yeah, let's play. We can't really have broken the tests by doing that, can we? But we can try and run this.
Okay. So let's go.
We can run it directly.
Go run cmd, and we have main. Thrust settings.
So far, so good.
Let's enter thrust settings.
Yep.
Meter says altitude, velocity. Stand 0. Sure, I'm putting this correctly. Just following this.
You should just be able to enter 50, and that should be enough.
Okay.
It only wants the thrust setting from you. So okay, that's not bad. I think we can do better. We need a bit more juice, don't we?
Yeah. Landed too hard. Let's do this again. 300.
Yeah, that's interesting. So yeah, I was just saying that you can't land with a positive velocity, but it seems you can. So maybe that's wrong. Well, we can sort of cheat actually, because we know from one of the tests exactly what your velocity will be at the next game tick if you don't do anything. It'll be minus 110, and you will have moved down 100 meters, which will put you on the ground. So you'll hit with a velocity of 110. So you need to offset that by at least 100.
So, for example, what?
If you're going down at 110, but thrusting up at 100, then your net velocity should be 10, shouldn't it? Which is about right.
And too hard. 110.
Cool. Wow,
okay.
That was perfect. That was a real greaser. So yeah, now I'm not convinced this game is very fun. At least, not yet. But that actually wasn't in the spec. So, during the requirements gathering phase, no one ever said this game should be really fun to play. What we wanted to do was just a game. And we have, but I think we can make it more fun. And one way is by changing these initial parameters, isn't it? Like basically you just get one turn here, and if you get it wrong, that's it, you're dead. So we would like a slightly more forgiving setup where maybe basically you get a few turns before you're anywhere near the ground, so you can get used to how the rocket responds and so forth. But that's really just a case of tweaking those numbers in the state vector, isn't it?
Yeah, here.
The machinery of the game is what we were concerned about getting right, and it's close to right, I think. So one thing that we could do as part of this is just make those numbers more realistic stroke more fun. And I think one of the features in the README was randomize the starting altitude, wasn't it? Randomize the starting position.
Starting position, yeah.
So, if you, every time you play the game now, you can just type in 100 or 110 and you'll win. So
it's easy to cheat.
Yeah. So to make it more interesting, it's a bit like those first-person shooter games, like Call of Duty, isn't it? Where all of the enemies always are in exactly the same place and emerge at exactly the same moment. You can basically run through a level when you know it well and just, the exact moment the guy's going to pop out from behind the crate and just shoot him, which is a bit unrealistic. So we'd like to add some more randomness to this, which would be fun, but that's a very good refactoring, so this is probably a commit point, isn't it? We could commit here before going on to break anything else.